So my name is Douglas Lee. I work in AWS, based in Seattle, and I manage a team of solution architects working with some of our top strategic ISV partners around the globe. And today I'm here to talk to you about how do we drive agility and control while operating at hyperscale on top of the Amazon cloud. So software today is moving a lot faster than it used to. It's easier for people to build a global distribution, and sometimes people do it in a matter of days. And startups now are able to take on giants in the industry with little to no funding ahead of time. They can just compete, and they're disrupting the market. Software is getting the hands of millions of people if it's popular. And a good example, would be like Pokemon Go, right? It kind of took the industry by wildfire, and a lot of people downloaded it in a very short period of time. Ability to move fast is paramount to the ability to fight off disruption. A lot of enterprises are trying to figure out how do they crack the code, how do they be like a startup, but at the same time, maintain the controls and the governance structures of a well-matured enterprise. The delivery model has also changed drastically. I mean, how many of you came from the old world where you had to buy diskettes, punch cards, and you had to basically load the software manually on the machine, right? There was even the days before SneakerNet. And then nowadays, I mean, software gets pushed to all these devices virtually, sometimes in your sleep overnight. It just gets downloaded if you set the right permissions on that. On top of that, we are seeing more and more disruptions in all the different industries right now. I mean, this is some of the examples of disruptive technologies that have only been around for less than a decade. Some of them less than 2 years, and they are totally changing the way we communicate and the way we function. And I'll just leave this on the slide for just a couple of seconds, and I'll just talk through maybe one or two. So I mean, nowadays we have cars, and very soon we'll talk about driverless cars, right? Any updates based on user inputs from time to time, leverages the cloud for its basically map updates. iPhone, I mean, iPhone started off from the iPod revolution, and nowadays, I mean, it's the new standard for smartphones. There's a lot of other smartphones out there in the market as well. Netflix, streaming. It's really changed the way we used to watch videos, because I remember when VCRs came out, we were all recording stuff, and then the DVRs, and then they had Hulu, Netflix. I mean, things are just changing the way things are being delivered nowadays. So moving on, what tools do we need to basically move faster in this new world, right? We need tools to manage software development release processes. That's very important. We need to be able to properly test and inspect code and defects, because we're not getting a free pass. Even though it's going faster, there's no free pass in writing good quality software that's robust and resilient. We need tools to help deploy applications. And nowadays, it's no longer deploying to a small subset of users. We're talking about deploying, going global in minutes, having a worldwide outreach of customers and user base. And most importantly, how do we monitor the applications and ensure its performance so that it's not being degraded over time? And that's very important. So if you think about it, software release process is not very dissimilar to making donuts. I mean, it's assembly line, right? And at the end of the day, when the consumer tastes a brand new fresh baked donut, he wants to feel that it tastes good, right? And for the same thing with software, we want to make sure that with the software that we release, people are satisfied with using it and consuming it. So this concept, how many of you have heard of this concept? You build it, you run it. I'm sure a lot of us in this room do. And this is, in a way, it's not shifting responsibility, it's really being more responsible and taking ownership of what you write. Does this look familiar? I mean, it worked in dev. Now it's not my problem, it's ops' problem right now. They must have messed it up somehow, right? It was great when I tested it. This finger pointing cannot exist in the you build it, you run it kind of world. How about this one? Or I'm just supporting my developers. I could ping the server. Apache is running. I'm not getting error messages. Ops looks great. Go talk to the devs. By the time you're done, your customers have left you, right? They are not happy. And the user experience will not be a good one. So now let's talk about you build it, you run it. What if you need to take on more complex subsystems where you may have a commercial off-the-shelf software where you don't have the source code to do remediation, and you need to go through customer service, support agreements, sometimes even escrows. What if you have an orphaned app? I mean, I've actually, earlier in my career, I used to work in a IT consulting firm as well as IT assurance firm, PricewaterhouseCoopers, and I used to do a lot of software assurance audits. And sometimes I have users tell me, I got no idea what this piece of code does. But we're so scared to turn it off because we don't know what's going to happen. And, or a server that's sitting under someone's desk, and we don't dare to pull the plug because we don't know what's going to happen to our operations if we do so. Or a little tiny app that someone has written so long ago that has become a critical kind of dependency in your software chain, and you no longer have the source code to remediate, which means that you can no longer upgrade. And when you run out of OS versions, guess what? Sometimes they're buying off eBay, old hardware just to maintain those pieces of code because they don't want to go through the hard rewrite process. There's also the question of how do you do custom, critical, and integrated apps that work, right? And this is all part of the mind-boggling challenges that you may face when you're doing the you build it, you run it kind of environments. And so let's talk about a very simple software delivery process. It hasn't changed really moving to DevOps. You still do building, testing, release, and then you do a feedback loop where you plan and you monitor as well, right? And then you have the customers as the end target where you release to, and the developers build the code. And operations runs this whole end to end. And the efficiencies that speed up this life cycle are very critical on how you move fast. And I'm just not going to spend too much time here. This is not a DevOps 101 talk, but there are just some very simple models out there where you do collaboration, and there's a slight overlap. You can have actually DevOps team being embedded, and they're stuck in a, they call it a war room, or you can call it a dev room. You can have DevOps as a service, which is another part of your company that has a whole team of DevOps experts, and they actually help coach teams on how they collaborate better. Or it can be a temporary DevOps teams, and they basically assemble at sprints, and they basically go on to their own functions, and they reassemble again for every sprint, right? So there's different models, and it can be anything in between as well. But the key concept here is where they overlap between the dev and the ops team, there needs to be very good monitoring and understanding of your environment and its performance. And that's kind of the key in the feedback loop. So let's look at Amazon. I mean, we've been doing cloud for about a decade now, but we've been a retail company for longer than that. And I want to share about some of the journey that we took in changing the way our Amazon.com site actually had to move to the future because we just weren't doing it fast enough, and we weren't robust enough to cater to our global consumers. So in 2001, and this is quite a long time ago right now, it's about 15 years back, we were entirely a monolithic application. It's a huge database, right? And we had all sorts of teams trying to basically keep that database running. Can you imagine once we scaled out to Europe, to Asia, to India, to the Middle East, to Latam, and we started building Amazon.com, .cn, Amazon.com, Germany, right? Or, I mean, all the different countries that we start building presence in, the monolithic application can no longer function in that new world. So there was a very painful decision made by senior management that we need to move into microservices. And so over the period of 8 years, and it was very hard, there was a lot of cultural transformations because people just didn't want to change what was not broken, basically. And it was not so much just doing development practice changes. There was a lot of mind shift changes across the teams. And we moved into this new concept of microservices, and we have this term called two-pizza teams. If you go online and look up two-pizza teams in Amazon, you find a lot of material on that. But in a nutshell, a team should not be larger than it takes 2 pizzas to feed. So when you throw a launch party, you order 2 pizzas, right? And that's kind of the concept behind it. And the reason being, if it's getting too big, it becomes unwieldy, and it's hard to support. But every single team knows its dependencies to the other teams. So we built a lot of tools to automate, because if you imagine the sheer size that we're running right now, we had to do a lot of tools to automate release. And we basically cut out the middleman, the wetware, the humans in between. All these release processes were slowly automated. So this continued to work very well for us. We had thousands of service teams across Amazon building microservices and practicing continuous delivery. It became the way of life at Amazon. And many environments, staging, beta, production, happened in parallel. We are completely continuous integration, continuous deployment, and continuous monitoring type of environment. And just to give you an idea of the sheer volume, on an average year, we basically do about 50 million deployments. And this is just Amazon.com's business. It doesn't even include the AWS business. Things went much better under this model, and every year we do a survey of developers to make sure that they are very happy with the way our tools are built, our dev tools, and our processes. And we felt that we can still improve, because in the DNA of Amazon, we have this thing called invent and simplify. So every year we come up with new ways to make things better. But one thing that has held true for all these years, since we moved from monolithic to a DevOps environment, is the pipeline services is what makes a key difference for developers. So continuous delivery equals happy developers. That's kind of what we learned in a nutshell. So let's talk about some of our customers, because we don't want to just say, no, Amazon said this and it must be true. We have a lot of other customers that we've worked with and partnered with in the AWS world that have kind of embraced this concept of DevOps as well. So Oscar Health, they have 45 developers, actually, and growing. They have 2 systems engineers supporting them. And they have a whole load of HIPAA requirements that they have to be compliant to. So they are a highly regulated environment. Airbnb, I'm sure a lot of you have booked vacation stays there. For a global business, with over 1,000 instances, they have 5 operations people running, following the sun 24/7. That's it. 5 people. Guild, it's kind of like, think of them like a Nordstrom's online kind of retailer, high fashion stuff. They have several hundred microservices. Everything there is built on self-service tools that extend the AWS cloud. And they almost run on T2 instances. What does that mean? They really take advantage of the burst features in T2. And they auto-scale up, auto-scale down, depending on the volume of their business at any point in time in the day. Intuit, tax season, right? They do TurboTax. I mean, there's millions and millions of people that file taxes through TurboTax every year. Can you imagine during tax season, which is like highly critical, and most companies say, freeze any changes, do not make changes to the production code, because this is our peak period. They actually run about 40 simultaneous experiments during that time. Why? Because they want to check if they can still do it under load and how resilient they can be. MLB, you heard all about it in the keynote, and you hear about it after the break as well, so I will not jump into that, but they also leverage the power of AWS to drive the StackCast features. And DevOps, think about it. One of our customers, Phil Calado from SoundCloud, they basically managed to compress from 66 days to 16 days in how they actually release. And they did it by basically embracing this DevOps example and creating a very good automated pipeline. And last but not least, from a customer sharing standpoint, CapitalOne, I'm sure you've all seen the advertisements online. They're very much a digital consumer banking product. And they have hundreds of code commits every day. They integrate every 15 minutes. It used to be once a month they do integration testing. Now they do it every 15 minutes. They do QA 4 times per day. It used to be once a month that they can do QA because it's such a big production, but now it's 4 times a day they can do it. Development is completely automated. And they release once per sprint rather than releasing once a month or once a quarter. They can do it for every sprint, and the sprints can be short sprints. So our customers should never be provisioning or managing or updating any resources by hand. And when I take resources, I'm talking about pipeline, dynamic infrastructure. It should be automated because in the new world of security, a change, as you saw in the keynote earlier, a change could trigger spikes in your application. It could trigger delays or lockups in databases. So if it's automated, you can roll back very quickly as well, and you can basically do kind of blast radius containment. So you build it, run it. It's all about building a really quality pipeline. And what does that mean? Faster, safer, consistent, but be able to visualize and monitor what's happening on your pipeline because it's going to get so vast and so broad that you need to have very good tools to really manage and visualize what's going on in your environment. So infrastructure as code is a practice where you take traditional management techniques and supplement it or replace it using code, right? And then use software development techniques to operate your infrastructure. So think about this. This is typical types of things that you have to deal with when you manage infrastructure on AWS Cloud. You have all the different resources, and there's 80+ services. But no, I'm just going to talk about a few here, right? VPC, EC2, and so on. And then on top of that, you have the operating system and host configurations that you need to do depending on what OS you choose to run, whether it's Linux or Windows or some version of Unix. And then you have all these different identity management products. So those are your operating and host configurations. Then you have your application configurations, and then you run the operations across that, and then you do deployment on top of that. Well, what I'm trying to say here, and I'm not trying to cover everything off in details, I just want to say that all this should be replaced by code. It should all be automated. And that's how we do it in Amazon Web Services and Amazon.com. And a lot of our customers that we worked with have been doing the same thing. So you can't move fast if you can't measure what's going on, because you're flying blind. If you're flying fast, you don't want to be flying blind, unless you're a Jedi. So metrics, monitor, logging, application performance monitoring or management is very, very important. So our customers are traditionally very weak in this, especially customers that are new to DevOps, right? And you can't make data-driven decisions without data. I mean, that's pretty obvious. Mean time to recover. It's basically knowing what failures are and understanding why they happen, the root cause of it. Without visibility in your application infrastructure, you cannot run them responsibly. So the question is, what tools are all of you using, right, to manage your environment and do logging and application performance today? So just some numbers. At Amazon.com, and this is numbers from last year, on average, the mean time we deploy something into production is 11.6 seconds. Remember I said we do about 50 million deployments a year? So every 11 seconds, we deploy something. We deploy it up to 1078 in an hour. We cap that number, okay? We also do 10,000 hosts receiving a deployment at any point in time. That's a mean number. Max number is 30,000 hosts. But if you think about it, because we have a fully automated pipeline, those numbers can be much higher. We do this for the reason that we've tuned it over time, and we found that this is a good number for us to do rollbacks, and you contain our blast radius. In the event that something goes wrong, we can unwind fairly quickly. But these numbers alone are pretty mind-blowing. And I mean, when I joined Amazon about 2 years ago, and when I first saw these numbers, it blew my mind, basically. So innovate faster than ever before. Builders don't like to hear things like, great idea, but I can't do it right now. Maybe next year, our IT supplier or managed service provider needs a change order, and we don't know if we can pay for it. We don't support that right now in the version of software or hardware we're running, or OS. So from idea to completed projects, there's so many different speed bumps or roadblocks along the way. But builders want to code, they want to make software, they want to move fast, right? And this is the stack of the AWS, and it continues to grow. This is the services we provide. And we continue to grow our global footprint as well. For example, now we have 12 regions, 38 availability zones. And we have 4 new regions that have been announced and coming soon, right? Examples will be London, Canada, right? And then we have a huge ecosystem of DevOps tech partners and DevOps consulting partners. And you can go to our website to check it out. And we also have, as announced today, the marketplace. And New Relic is one of our latest additions to the marketplace, where just October last year, we had 142 million EC2 hours provisioned through marketplace. That's a pretty big number. So in summary, DevOps plus dynamic infrastructure allows you to do agility and control at scale. It's hard for customers to succeed without considering building DevOps, because the you build it, you run it concept needs to stick, right? Customers who ignore it may not survive the next decade because competition is coming fast and furious. And like I said, the startups can now compete with giants. I mean, for example, some of the fintechs, there are startups now, are basically eating the lunches of banks. Banks that are 100-year-olds, right? And it's easy for a startup now to basically take over if they have a great idea. The next thing is, you don't have to start with DevOps end-to-end. Start small. Even when you're running on-prem right now, doesn't mean you cannot have a DevOps team. Experiment with those examples that I gave earlier. And the concept here applies to all facets of IT, IT, development, security, QA. In fact, in Amazon, if you look up DevOps security, we actually have a whole track on how do you do DevOps security as well. And so the takeaway I'd like to leave you all with is continuous integration and delivery. It's very important. Think of your infrastructure as code. Monitor metrics, logging, application performance management. It's important. APIs, microservices management are your friends. It's complex, but they are helpful. And lastly, don't forget, communications, collaboration across teams. The human factor is still very important. And sometimes things break because people don't talk to each other. So with that, thank you so much.